Hi guys, in this video we are going to discuss the xy plane or Cartesian coordinate system and some of the graphs of straight lines, circles, etc. Cartesian coordinate system. Each point on a flat two-dimensional surface called a coordinate plane or xy plane is associated with an ordered pair of numbers called coordinates. This system of xy plane is called a Cartesian coordinate system in honor of René Descartes. See this graph. This is an xy plane. You can find a horizontal axis called x and a vertical axis y. Okay, here this part is called the first quadrant, and here it is second quadrant, third quadrant, and fourth quadrant in anti-clockwise. So every quarter of this graph. In the first quadrant, both x and y will be positive. The second quadrant, x will be negative, y will be positive. The third quadrant, both will be negative. You see, first quadrant, both are positive. It's opposite. Third quadrant, both are negative. In second quadrant, x is negative, y is positive. It's opposite. In the fourth quadrant, x is positive, y is negative. Okay. In this way, you can understand the coordinate system. You can plot any given points. First, I would like to show you what is x is equal to a constant in an xy plane. This is a Cartesian system or xy plane, you can say. X is a constant, call it 4. X is fixed at 4. Y is allowed to change, that's the meaning. So this is the line. Y is changing from positive infinity to negative infinity. Throughout this line, x is fixed. So this is a straight line when you say x is equal to 4 in a two-dimensional plane. Similarly, if I say y is equal to 2, then y is 2. It's fixed here. Throughout this line, y is 2. X is changing from negative infinity to positive infinity. They intersect at some point. This point at which x value is 4 and y is 2, the intersecting point is the ordered pair where x coordinate is 4 and y coordinate is 2. Okay, in this way you can plot any point on this graph. If I want to plot to -1 and 6, x is -1, it's here, y is positive 6 here. So this is the point of the intersection of the lines x is -1 and y is equal to 6. Similarly, you can plot any point on this graph, and you might have known this one before. Definition of equality of ordered pairs. Two ordered pairs are equal, then the coordinates are equal. X coordinates are equal and the y coordinates are equal. A and C are equal. Similarly, B and D are equal. That's what given here. Example, 3 comma y is equal to x comma minus 2. From this you will understand x is equal to 3 and y is equal to negative 2. Distance and midpoint formulas. Look at this graph. You see, we are going to design a formula for the distance between the point P1 and P2. Okay. Vertically, when you look, the difference in y1 and y2, the y1 and y2 values the distance between this y1 and y2. We call it simply del y. Here, the difference between two constant values in one line is this descent is given by this absolute value. Absolute value in the vertical axis. The distance in the vertical axis is y2 minus y1 under absolute value. The distance in this horizontal line is given by x2 minus x1. You can call it del x. Okay, now this hypotenuse distance is what we require as a d. So we can use Pythagoras theorem. Pythagoras theorem to write the formula for d. D square is equal to del x square plus del y square, isn't it? Therefore d is square root of this del x. Del x, you can say difference between x2 and x1. x2 minus x1 whole square, and del y is y2 minus y1 whole square. That's all. So the difference between x values and the different square plus the difference between y value squares and overall square root will give you the distance between 2 points. An example has been given, the formula has been given here. We will take an example. Find the distance between points on xy plane. First point, this is x1 y1, x2 y2. You can change them. This can be x1, isn't it? One of them should be x1, the other one should be x2. That's all. You can write x1 minus x2 or x2 minus s1. So the formula for distance d is square root x value, difference between x value, minus 2 minus 4 whole square. The difference between this and this, isn't it? Minus 2 minus 4 whole square, plus difference between y values, minus 2 minus of minus, here it is plus 8 whole square. Overall you get this is minus 6 square plus 6 square. So you can take a 6 out of the square. 6 square root of 2 is the distance between the 2 points given here. The middle point of line segment. So if I have 2 points P0, P1 and P2, what is the formula to find the middle value? If P1 is x1, y1, and P2 the other point x2, y2, then the formula for the middle point MP is the average of x2 and x1. So you can write x1 plus x2 over 2 x value. The y value is y1 plus y2 over 2. So this is the formula for finding middle value, middle point. Okay, now use the formula of middle point here for this example. Minus 7 plus minus 3 over 2, 0 plus 4 over 2, that is it. This is minus 10 over 2 minus 5 and 4 over 2, 2. That is the way you can find a middle point. Well, what's next is a graph of an equation. How to draw graphs for given equation. Let's discuss first straight lines. If I want to draw a straight line, y is equal to 2x plus 1. There are different ways. You can give x values. X is starting from minus 2, minus 1, 0, 1, 2, and you can get y values. Minus 2 into, so substitute the minus 2 here. Minus 4 plus 1, is it minus 3? Check. And when x is minus 1, this is minus 2 plus 1, minus 1. When x is 0, y is 1. When x is 1, 1 into 2 plus 1, 3. X is 2, 2 into 2, 4 plus 1, 5. So when you plot the pairs, xy pairs, x is minus 2 here, x is minus 2 here, y is minus 3. So this is the point of intersection of minus 2 and minus 3. X is minus 1, it's here, y is minus 1. Both are meeting here. X is minus 1, y is minus 1. So they intersect at here, isn't it? Next, x is 0, y is 1. So here x is 0, y is 1. X is 1, y is 3. X is 1, y is 3. Here you can find x is 1, y is 3, isn't it? X is 2, y is 5. It's here. So connecting all the dots will get you just draw a straight line infinitely larger on both ends. This is y is equal to 2x plus 1. See the question, every time should I give the x values to get to y values and draw this one. This way also you can draw. There are different ways. I can show you different ways of drawing a straight line. Okay, now if I write 2x plus 3y is equal to 6. Before introducing this example, I will tell you one more information. X over a plus y over b is equal to 1 is also a standard form of a straight line. Here x over a says a is, for example, if I write x over 3 plus y over 4 is equal to 1, then this is a straight line whose x-intercept is 3 and y-intercept is 4. So just join these 2 points, you will get the straight line. Okay, go through this point. This is the equation x over 3. Now what is the exact equation? So find the least common multiple of 3 and 4. Multiply by this number. Can it be 12? Multiply by 12. This equation should be multiplied by 12. So this is 12x over 3 plus 12y over 4 is equal to 12, which is 4x plus 3y is equal to 12. So this is the line. This is 4x plus 3y is equal to 12. Okay, so if you write any equation in this intercept form, then you can easily draw the straight lines. This is one case. So for this example, 2x plus 3y is equal to 6. Divide this equation by 6. You will see x over 3 plus y over 2 is equal to 1. So x-intercept is 3, y-intercept is 2. X-intercept is 3 already here, y-intercept is 2. We will draw the graph here, line. Join this 2 and 3. This is our required straight line. This is another method of drawing a straight line. Yet another method is very simple. Give x0, y0. For example, if you want to draw y is equal to 4x plus 2 and give x is 0, then what is y? X is 0, here 4x part will be 0, y is equal to 2. So this is a point. X is 0, y is 2. Can we plot this point? X is 0, y axis. And remember, y-axis is called, the equation of y-axis is x is 0. The equation of x-axis is y is 0. Okay, you should remember this one. And x is 0 means you are on y-axis. This is on y-axis and 2 units. This is the point, first point. Noted. When y is 0, in the same equation, when you put y is equal to 0, you get 4x plus 2 is 0. So 4x is minus 2, x is minus 2 over 4 is minus half. X is minus half somewhere here between 0 and negative 1 here. So join these 2 points, we can draw the line, isn't it? Also you can widely guess some graphs. If you write y is equal to mx plus c, if m is positive, the line will be inclined towards the right, this way, isn't it? And if m is negative, the line will be opposite direction, this way it will be looking, right, in this left side. And if m is 0, it is parallel to x-axis, this way. If m is infinity, it will be perpendicular to x-axis. So there are some other techniques to that. And of course this, when x is 0, this is y-intercept as well. So there are many different techniques to understand straight lines. You can further use any of the techniques that you like. Yet another kind of graph which involves absolute value terms. Okay. Generally, when I say y is equal to absolute value of x, it's is an equation looking like a V this way. It goes y is equal to x here, y is equal to negative x here, isn't it? This is suppose y is okay. This is a V kind of graph for y is equal to absolute value of x. Okay, for graphs I need to give you such graphs. I need to give you another information. If I write y is equal to f of x, if I know what is the graph of f of x, and then you want to draw f of x plus some constant, for example 2, isn't it? When I add 2 outside of the function, then the graph of the original function f of x moves 2 units up. Therefore, if I write y is equal to absolute value plus absolute value x plus 2, it will be the same v from here 2 units up. Is that clear? Yet another case, if I subtract instead of addition, if I subtract y is equal to absolute value of x minus 3, it will go, the same v will go 3 units down. The same v will go this way 3 units down. Okay, what happens if I add or subtract with the variable, not with the function? That is, addition or subtraction outside will move up or down, move the graph up or down. What happens if I do addition or subtraction inside the function? We know y is equal to absolute value of x, so v, isn't it? Okay, if I add absolute value of x plus 2, then this v moves left side 2 units. It will be the same v from here to here. Okay, then if I subtract a constant with the variable, it will move right side 2 units, 1 and 2. So it will be v from this point. So this basic idea will help you to draw some graphs of absolute value equations or parabolas, some other functions as well, isn't it? So the concept is you must know the graph of f of x. Then if you add any constant outside, it will move up. If you subtract any constant, it will move the graph downwards, the c units. Okay, c units. If you add a constant to the variable x, it will move left side c units. If you subtract a constant with the variable, then it will move right side 2 units. So this basic concept may help you. Now look at this given example. Okay, y is equal to x plus 3 minus 2, x plus 3. You are adding a constant. You are adding a constant to the variable. Okay, how many units? 3 units. So you should move 3 units left. 3 units left. Center of v. So general v is here. General v is y is equal to f of x. Y is equal to, this is y is equal to absolute value of x. Now we will draw the given graph. I understand. Okay. 3. When we add a constant with the variable, the graph moves left side. So 3 units. So it will be here. This center point will be here. And minus 2 at subtraction with the function. So when you subtract any constant outside, it will move 2 units down. So the center is now here. The same v, isn't it? Going this way and going this way. Roughly you can guess the graphs. You don't need to exactly give x values and y values, isn't it? Similarly, you try the second graph. X is subtracted by 2. So it will move 2 units to the right. isn't it? Here the center point, and you are adding 3 to the function. So addition outside, it will move 3 units up, it will be here, and the same v here. This is y is equal to absolute value of x minus 2 plus 3. You can check by giving rough values for x. When x is 0, this is 2 plus 3, 5, isn't it? Yes, it will intersect at 5. When y is 0, what is x value? You can also check here. That it will not intersect with the x-axis, this curve, okay? Roughly you can verify. This is the way you can write this absolute value functions. Next, kind of parabola, if an equation is given here where the degree of x is 2 and degree of y is 1, it is representing a parabola, and you must know y is equal to x square. It's a normal parabola. You can give x values and find y. Give minus 2, minus 1, 0, 1, 2. So y is 4, 1, 0, 1, 4. If you plot these points here, x is minus 2, y is 4. This point is here. X is minus 1, y is 1. Here. X is 0, y is 0 here. And 1, 2 is 4. So when you plot these points, this will be the U-shaped curve, which is y is equal to x square. Now you know the same trick. If I add plus constant, this will move 2 units up, isn't it? If I subtract anything with this x, then it will go c units down. If I write y is equal to x minus 3 whole square, if subtraction is to the variable, the same graph moves 3 units right. Addition is with the variable, then it is moving c units to the left. So if you use this technique, it will work. Now let us see how to address this question. Okay, y is equal to x square minus 2x minus 3, and this must be a parabola. If the equation involves some y terms and the maximum degree of y is 2, then it will become a circle that we will discuss later on. If there is another y term as well. So, okay, we will discuss. This is a parabola and how to figure it out. I just write this negative 3 to the left side. That means I am going to add 3 on both the sides. It will be y plus 3 in the left side, x square minus 2x in the right side. Now we must know how to complete the perfect square, isn't it? To complete the square here, the term to be added is 1. Isn't it? You take this minus 2 from here, divide it by 2 and square it. This is 1. So when I add 1 to the left side, add 1 to the right. The right side you add 1, and then left side also you are adding 1. What's next? Simplify. Simplify. In the right side it is x minus 1 whole square. Left side it is y plus 4. Simplify further. Y is x minus 1 whole square minus 4. General parabola y is x square. We just drawn it, isn't it? It is 2 and then 4. It's going this way. 1 minus 2 is this way. So this is y is equal to x square. So what kind of parabola is this one? The variable is subtracted by 1, so the center is moving 1 unit to the right. Okay, then the function is subtracted. Outside subtraction, inside also subtraction. Outside subtraction moves it down 4 units. So 1, 2, 3, 4. The center is here. For the new parabola, center is here. And from here we are about to draw a parabola. But before that, what are the x and y intercepts? If you know that one clearly, we just move this parabola from here to this one. It will be something like this. But we need to exactly know where it intersects with the y-axis and x-axis. Roughly we will check here. Okay, when x is 0, it intersects y, isn't it? The curve will intersect y axis when x is 0. Put x equal to 0 here, which is y is minus 1 square is 1, 1 minus 4 is minus 3. So this will intersect the y axis at minus 3 here. So put y is equal to 0, what do you get? X minus 1 whole square minus 4 is 0. So x minus 1 whole square is 4. X minus 1 is plus or minus 2. X minus 1 is minus 2 gives x is minus 2 plus 1 minus 1. X minus 1 is positive 2 gives x is 3. So x intercepts are minus 1 and 3. That's all. Now you got the parabola, isn't it? This way it's going on. So this point moved to 1 unit right and 3 units down, and the same parabola is here. Okay, this is the way we can roughly identify the graphs. In this MCQ type questions, either graphs will be given, you need to identify the equation, or you will get curves, graphs, and then you will identify you will get the equation, then you will identify the graphs. Next, equation of circle. Okay, if I give some others before going to the other topic, if I give you a different kind of parabola, y is equal to x minus 2 whole square minus 4. Can you guess the graph? Y is equal to x square, same parabola, 2 units right and 4 units down. The center will be here, and y intercept, x intercept, roughly you can guess. It's a parabola, isn't it? And when x is 0, this is y is 4 minus 4 is 0. When y is 0, so this is a point here. X is 0, y is 0 is intersecting this way. Going, and it will be the right side of, when y is 0, you get any other value, x minus 2 whole square is 4, x minus 2 is plus or minus 2. X minus 2 is equal to plus 2. So x is 4, on the other side it will be x is 4. This way it's going. This is another parabola. So in this way, roughly, if you know where this middle point is moving, you can understand the graph of the parabola. The next one is equation and the graph of a circle. A circle is the set of points in a plane that are a fixed distance from a specified point. The fixed distance is called radius. Fixed distance is radius of the circle, and the specified point is the center of the circle. It means that there is a fixed point and a distance r, a radius fixed. Now if this point is rotating, collecting all the points in this track, it will form a circle, isn't it? This is the definition of a circle. The general equation of the circle is going to be written here. When I write a general equation as x minus a whole square y minus b whole square is equal to r square. This is the general equation of a circle, where center of the circle is this a and b, and radius is r. Okay, for example, if I write x minus 3 whole square plus y minus 1 whole square is equal to 3 square, then its center is 3, 1. Center is called C, A and B. So C, A and B, x minus A, y minus B. So minus is already there in the formula. Pick up only this number. 3 and 1. 3 is x value, y 1 is y value. So it is the center is following the first quadrant. You see, x is 3 here, y is 1. The center is here, center of the circle, and radius r is equal to 3 square. So 3, this is radius square, so radius is exactly 3 units. So from this center, 3 units in all direction, 1 2 3 units in this direction, 1 2 3 units in this direction, 1 2 3 here, 1 2 3 here, and this way roughly draw the circle. Okay, that is it. So the center of this circle is lying in the first quadrant. That's the meaning. Just take another example of circle. X plus 2 whole square plus y minus 3 whole square is equal to 4. Now what is the center point? Find the center point. See, center x minus a. So there is, it should have been x minus of minus 2, isn't it? Then only it will be plus. So see, the x value for the center is minus 2. This is direct 3. So x is minus 2 here, y is 3, center is here, and the radius is 2 square, which is 4. So radius is 2. R square, radius square will be in the right hand side. So 2 square is 4, the radius is 2. From here 2 units in all direction, pick 2 units in all direction and join them. You will get a circle whose center is in the second quadrant. In this way you can identify the center. If I write x square plus y plus 1 whole square is equal to 3, what kind of circle is this? You see, there is no a. It is x minus 0 square plus y minus of minus 1 whole square is 3. So center is 0 comma minus 1. X part is 0, y part of the center is minus 1. X is 0 is on the y axis, y is minus 1 here. The center is on y axis, in the negative side of y axis, and radius is square root of 3. It should have been square root of 3. This is right side should be r square. R square is 3, r is plus or minus root 3, but radius is a positive quantity, so write positive square root of 3. It is around 1.732, isn't it? Close to 2 units. So we can write it to around 2 units this side, around 2 units this side, and this side. Connect them, you will get a circle roughly. So there are different kinds of circles. Either the circle can be centered in the first quadrant, or fourth quadrant, or third quadrant, or second quadrant, or centered in the origin. You know, if I write x square plus y square is 1, what kind of circle is this? X square plus y square is 1. X minus 0 whole square, y minus 0 whole square, and 1 square on the right side, which is whose center is 0 comma 0, the middle point, origin, and radius is equal to 1 unit. So 1 unit all directions. So there is small circle, isn't it? Very simple circle, this one. And there are different circles which can be centered on x-axis alone if y part is 0. Negative side of x-axis also, positive side of y-axis also. There are centered different kind of circles. Okay. If I get another different equation, how to identify a circle of it? I'm going to give an example here. See. X square plus y square minus 8x plus 2y is minus 8 is equal to 0. Is it a circle? Certainly it is a circle. It is a circle. How can I get the equation of the circle here? I am clubbing x and y, you see. and constant to the right, x square minus 8x. Okay, next I need to write a term to complete the square. Here I will write it, but the y terms are y square plus 2y. I clubbed x with x and y with y. The constant term will be in the right side, 8. Now to complete the square of these two terms, I need to add the term x square minus 8x. So divide this 8 by 2 and square it, which is 8 divided by 2, 4 square is 16. So I add a 16 here. At the same time we add the 16 to the right side and complete the square for the second two terms. So the y square plus 2y. To complete the square, the term to be added is 1. Similarly, add 1 to the right side. Now these three terms will be a square term, x minus 4 whole square. The second three terms will be another square term, y plus 1 whole square. And the right side totally it is 16 plus 8, 24 plus 1, 25. Now are you getting the general equation of the circle whose center is 4 comma minus 1 and radius is equal to 5. Center is 4, x is positive, y is negative. X is positive 4 units, y is 1 unit. Center is here, negative 1 y. Center is 4 comma minus 1 and radius 5 units. You can see 1 2 3 4 5 in this direction, 3 4 in this direction, 1 2 3 4 5 here. So it is a big circle that goes beyond our limit. So this may be a rough graph of the circle. So completing the equation of the circle is just like that, completing the square, and use the constant to the right side. Okay. Some examples of parabolas are given here. To draw this parabola, y is equal to x square is general parabola, you know. And when you add some examples of parabola, you practice it. Okay. The idea has been already given. Roughly checking. When x is x square, when you add a plus, it will go 2 units of this parabola will be from here upwards. To find exact points, give x value and get y value. Okay, roughly you can figure out the graph. Here for second example, the same parabola which is moving 2 units to the left from the center to this point, 2 units, and 4 units down, 1 2 3 4 here. This is the point. The origin is translated to this point where it is 2 comma x is sorry, this is slightly changing. When it is subtraction inside, we have to move 2 units to the right. Okay, and subtraction outside, 4 units down. So this is 2 comma 4. This center point 0 comma 0 translated to 2 comma 4. Now you can find y-intercept by giving x equal to 0. x equal to 0. This is 4 minus 0. We have drawn this one. So this will go through this way. This, from this point it will go towards this direction and this direction. This is the curve for the second equation. Okay. Now some practice problems are given. Before concluding this one, I want to give a different example for a circle. If I give a center point 2 comma minus 3 and any point on the circle, any point P on the circle, call it 4 comma 5. How can we draw the circle? There is no radius, only center is given, isn't it? So if I know center is 2 comma minus 3, where is it? x is 2, y is negative 3. So the center is here, but I don't know radius. I have a point on it. Point is 4 comma 5. Where is 4 comma 5? X is 4, x is 4, y is 5. So a point is here. So the circle is going this way. So the radius should be calculated. The radius, the distance between 2 points. Center is 2 comma minus 3, and the point on the circle here is 4 comma 5. This distance is radius, and we have the formula for distance. So radius is our distance between this point, which is square root of 4 minus 2, the x values, 4 minus 2 square plus 5 minus of minus 3, 5 plus 3 whole square. It will be 4 minus 2. 2 square is 4. 5 plus 3, 8 square is 64. And this is square root of 68. Can be written as 4 times 17. And it is 2 times square root of 17. Isn't it? Square root of 17 is slightly above 4. So this is around 8. There will be 8 units, around more than 8 units, the radius, which is 2 times square root of 17. Now if you know this radius, on all direction you can use this radius and form this circle, isn't it? A big circle. That's it. So find the radius. There you can write the equation of the circle. X minus 2 whole square plus y plus 3 whole square is equal to 68. Square root of 68 is radius. So square it is 68, isn't it? This is the equation of the circle. And if I give you end point of the circle, end point of the diameter, there is a circle, the end points are given 2 comma, I can give you end points. End points of the diameter (2, 3) and minus 4, 11. Where are those points? 2, 3. X is 2, y is 3 is here. Minus 4, x is minus 4, y is 11. X is minus 4, y is 11. 11 is far away, somewhere here. Minus 4, 11. So the line joining these 2 points will be diameter. Find the distance between them, divided by 2, which will get you radius, and midpoint will be center. Midpoint of this diameter will be the center. That way you can try to find the equation of the circle. Okay, that's it. And do practice this kind of problems. Thank you very much.